Okay. So right then the voltage at the bus is 15 kilovolt. And the power factor, right, and it delivers 100 MVA at a power factor of 0.8 lagging. Now, first of all, this is a 16 kilowatt machine, but it's only delivering 15 kilowatt. So the per unit voltage will be 15 divided by 16, which is 0.9375 per unit. And then it's delivering only half the power. So S per unit will be 100 over 200 at an angle of minus 36.87, which is 0.5. Now, remember we want to know what the power is now, and the current. So I is S over V. So that will be 0.5, and the voltage is 0.9375. So that means, what is it? 0.5. It'll be 0.533. Angle minus 36.87. You guys with me with this so far?
Yes.
Because remember, it's not supplying full load, only half load. And then the current will also be less. Because I is always S over V. And now we must calculate the induced EMF. So E angle delta will be V angle 0 plus IA XS angle beta plus or minus 5. So that will be 0.9375 angle 0 plus 0.533 minus 36.87 times 1.65 at an angle of 90. You got that? Normally we say that E is equal to 1 plus IAXS, but because the voltage is now less, so we just use that. And that gives us 1.6258 angle 25.7 degrees per unit. You happy with that? Now the second question says, if the field current of the machine is reduced by 10%, while the mechanical input to the machine remains constant, determine the new value of the load angle and the reactive power delivered to the system. So now if we reduce the excitation, E becomes less. So E2 will now be 0.9 of E1, which is then 1.4632. Okay, the power being the same, then we have, remember, it will be 0.5 times 0.8. That'll give us 0.4 per unit. Because if it, that will give us 0.5. Okay.
That 0.8, is it?
Yeah, that's a power factor. Yes. Because P is S cos phi.
Yeah, yes, I remember that part.
Okay. So now the powers being equal, we can say that V1 or VE1 over X sine delta 1 is the same as VE2 over X sine delta 2. You agree? So now we have to determine sine delta 2. That will be Px over V, VE. And so that will be arc sine, and then it's 0.4 times 1.65 divided by V, which is 0.9375, and 1.436. All right. That gives us 28.76 degrees. And then the reactive power, Q, is V over X, E cos delta minus V. So again, V is 0.9375 over 1.65. And that was 1.4632.
Jonathan, can you leave the page, please?
Mm.
Okay. Thank you.
Right, but cos of 28.76 minus 0.9372375. Sorry. That gives us a value of 0.1962. Let me just move this paper. 0.1962. Okay. Any questions so far? Right, then the third question says, the prime mover is next adjusted without changing the excitation so that the machine delivers zero active power to the system. So we must compute the new load angle and the real power being delivered. So if Q is equal to 0, then with that equation, we have VE over X cos delta is equal to V squared. You agree with that? We just manipulated that formula.
But
Yeah?
why are you leaving that X on V2 on that V squared?
Can't you see it?
Like, yeah, now, yeah, now I can agree.
All right, so now we scratch everything and we find cos delta is V over E. And therefore, delta is arc cos 0.9375 divided by 1.4632. And that gives us an angle of 50.16 degrees. Okay? All right. So now the power, P is VE over X sine delta, 0.9375, 1.4632. 1,65 times sine of 50,16. That gives us 0,638 per unit. Okay. Then question 4. What is the maximum reactive power that the machine can deliver if the level of excitation is maintained as in 1 and in 1.1 and 1.3? So that means V, E, and XD are fixed. So Q then we remember is V over X, E cos delta minus V. Now remember, when we want to determine the maximum value, we have to differentiate the equation. So dq, the delta, is then minus VE over X sine delta. And that must be equal to 0. And that can only be 0 if delta is 0. So therefore, Q maximum is going to be V over X into E minus V. 0.9375 over 1,65, 1,4632 minus 0.9375. And that gives us 0.2987 per unit. Right. Now for the first part of the phasor diagram, we have,
Sorry, sir.
yes.
Yeah, Papa, that last question that you did now. We differentiate in respect to
Delta.
delta, no?
Yeah, because that is going to cause Q to be the maximum if delta is 0. And then because if delta is 0, then cos delta is 1.
1, yeah.
Okay. Now remember, on the phasor diagram, we only have X. So I X is perpendicular to that current. Right? And then it goes there. So that's E1. And that angle was 25.84 or 25.7. Okay? Then it became a little bit less because we said it's 1.463. So E becomes smaller by a certain amount. And when will the current be perpendicular to that? When the current is more or less in that direction. So that's IA2, E2. And then for the maximum value of E is when it's perpendicular there. That is when delta is equal, delta is equal to 90 degrees, then we get the maximum E. So that's going to be that one. So the current will be in phase there, it's 90 degrees up, and that is point C. Okay. So remember, a phasor diagram is just a graphical representation of your answers. Remember, we got 1.6258 at an angle of 25.7. And then we reduce the induced EMF to 1.46. So the power becomes half and the power factor changes so that E now becomes that one. And that angle was 28.8. That angle there. And for the last one, what was the angle there? Oh, we could have calculated it, but the only thing is, now remember, this is just the all three conditions put together. The first one, like I said, would have been that one, perpendicular, and there it goes. And then on the second one, it would have been there. And now E was less, and we have the angle there, which was 28. And because the current would have been perpendicular, it would have been a little bit less, the power factor like that. And the biggest one, the last one, was when that was 90 degrees. And then that was E, and V, and I was in phase. Okay.
Can you lift up the page a bit, sir?
Okay. That was
So, sir,
yeah.
if I'm to put these whole three situations like in parts like you did now, will it be wrong?
You see, the problem is then we can't really see the relation between them.
You can't see the relation.
Yeah, because here you can see that the power of the current would have been less there and it would be leading there. Yeah, okay, it would. I don't think it would be wrong. You can do it that way.
Okay.
Right, then question about the transformers. The only problem there was in the beginning, I gave you two different values. That was 0.1 and that was 0.15. So the current is not the same anymore because now it is inversely proportional. So IA is going to be I load times 0.15 divided by 0.25. And IB is going to be I load times 0.1 over 0.25. That's where most of you guys didn't get that right. But the rest was okay.
How? I don't get that part. I'm lost.
Listen, it's the same as two resistance in parallel.
In parallel, yeah.
So
you have
they divide the current inversely proportional to the impedance.
Yeah. What was the question on the? I still can't remember.
On
I was
B,
asking for.
now the first one says, compute the complex power transferred by each transformer if there were no tap change. And then the B part is when we've got a 5% tap change. So here the current was 1.18.
1.18 at an angle of
Yeah, 1.118 angle of minus 25.6.
Minus 25.6 somewhere.
Yeah. So if you do that calculation, that would be 0.671 minus 25.6. And that one would be 447 angle minus 25.6. So the S would be 0.671 at an angle of 25, and SB would be 0.447 at an angle of 25.6. All right. You happy with that?
At least now I see something.
There
was nothing challenging.
Pardon?
There was nothing challenging.
No, you just had to remember all your rules from S1.
Yeah, I see now.
All right, then the last question. Most of you got that right, except for a few things. DS of the bundle, that was for the 7 strands. You got that right, is this 49th root of 0.7788 r squared, and that was, radius was 5 millimeters now. And if you got that right, you got 0.0108. Now, most of you rounded it off to that, and that was not right. And that was the answer that you should have used. And then DS for the bundle, like that, was then we used that radius, which was 0.01 0.010884 squared times 0.45 squared. That gave us a value of 0.0617. And then D equivalent, you got right. And then L, that would change because now, due to your rounding off error, it became a little bit less. Okay, I didn't penalize you on that. I got 1.02 microhenry per kilometer. Capacitance, the same thing. DSC, first one, we all calculated to the 49th root R and whatnot. And that was 0.01128. And for the complete bundle, that became square root of 0.11028 squared times 0.45 squared, and that was 0.07125. And therefore capacitance is 2 pi epsilon naught over the ln of D equivalent over DAC. And that became 11.229. Okay, now we came to the impedance. R was equal to rho L over A. Now that was 1.778 times 10. That was given as rho. 10 minus 8, it was 160 kilometers. Pi d squared, which was that ds of the bundle, 10,884, 10 minus 3 squared. And that gave us 7,644 ohms. L is 1,02 times 10 minus 6 times 160. And that gives us 0.163. XL is 2 pi FL, and that gave us 51.23. Z is only R plus JXL. We don't consider capacitance. So that means it's 7,64 plus J 51,23. That gives us 51,8, angle 81.5. And Z per unit is 51,8, 81.5 times kVA 100 times 10 to the power of 3 divided by the voltage squared, 345. And that was 0,044 angle 81.5. You know what that means? Quod erat demonstratum. Or like you say, quite easily done. Right, any other questions that you have?
That's that unit, I missed that part. How do you calculate it?
Z. Which part?
Again?
Which part did you not get?
This Z per unit.
Because it is Z actual times S divided by V squared. Remember?
Oh.
I
Yeah, that like
is S over
I
V.
over V. Yeah.
And then S, and then you get that formula where you get Z is S over V squared.
No, I saw a mistake on that correction that I wrote. I think that part of inductance, I added capacitance, and then again I didn't multiply by that distance on the inductance part.
I saw that. Most of you didn't do that. Right, the paper will be basically the same. Question on alternator, question on transformer, question on capacitance and inductance. So hopefully now you will be set.
As long as you don't trick us.
That wanted to write another test.
Pardon?
Is that for those that wanted to repeat this, the case?
Not to repeat, it's the ones that failed it.
Oh, okay.
All right, so are we done?
So you won't trick us this time. So.
Pardon? Yes, you better.
You won't trick us.
Yeah.
Hmm?
Yeah, you can just fax me 100 Rand, then I'll be fine.
100 Rand, sir.
Yeah, you fax it to me or email it.
How do I fix it? How do I email 100 Rand?
You make a copy of it and then you email it.
You won't use it. That's a fake. That would be fake, sir.
Yeah, not to worry. Okay, guys. Let's hope you pass the next one.
Sure.
Yeah.
I'll try to redo.
What time are we writing?
6 o'clock.
On Monday.
Yeah.
Okay, thank you, sir.
You guys got the
I'll try
notes
to-
that I sent you?
Sorry?
Did you guys get the notes that I sent? I
Yes, we
sent
got them,
them to
sir.
Warren.
Which notes, sir?
That was
Where did you send them?
chapter 6 and 8 and whatever.
Yes, sir, we had them.
Okay.